So today we're going to be looking at zoning comparison. What's the difference and when do we need to use multiple furnaces? When should we maybe use a ductless mini split? Or when zoning's appropriate? And there's a lot of overlap between the three systems, and we're going to discuss some of the pros and cons with them, and then take a look at a couple of different houses and talk a little bit about why that would be a better fit for that application. So when we take a look at them, we got our ductless mini splits, we have our zoning systems, and we have our multi-systems. And all three of them do have a place in the HVAC industry. It's not that one option is greater than any other, but it's more knowing what option is going to suit our customers' needs the best. Because each home is a custom application. So one size fits all isn't going to pertain to every single home. We have to look at our customers' homes. We have to look at what they have available to them and then be able to discuss those options to match the comfort with what they're looking for. Multi-systems though, you have multiple furnaces and then you have multiple condensing units that tie in with those furnaces, multiple duct systems. Some of the benefits to them is that there's a backup. So if one of the systems does go down, a repair need, there's a second system that is still operating and you're not left without heat waiting for repair, waiting for a part to come in. You have more control with multi-system because you've got two furnaces, two thermostats, and that's a type of zoning. But also when you have a full forced air system, you've got a lot of options for IAQ. But with multiple systems, you may or may not have lower operating costs. You may or may not have higher operating costs. It just depends on what it is you're doing to maintain the comfort in your home. Are you treating it as true zoning where one area is kept at a different temperature based on how you're using the home, or are you trying to maintain the home at the same temperature throughout the entire home? And that's going to affect your operating costs. Some of the cons that we run into though when we have multiple systems is there's a lot more equipment to purchase. So that essentially doubles the equipment cost or the material cost for the job. There's more ductwork, more venting, line sets, gas, piping, all of that. So with all those extra materials, that really adds to the cost, but that also adds to the labor. It's a lot more labor intensive when you've got to put in multiple furnaces, when you've got to run all that extra ductwork, cut all those additional holes. And depending upon how the home is laid out, it might not be easy. A lot of the homes that I ran into in the new construction market, builders want to give the HVAC contractor as little room as possible, and they want to maximize the occupancy. Those are all things to take into consideration. When we have multiple pieces of equipment, so two furnaces, two air conditioners or more, there is a lot more space needed. And then once we start seeing that on the outside of the home, they don't want you to spread out those air conditioners to give them a proper footprint. They don't want you to give the spacing between the air conditioners that the manufacturer would want. So you end up recirculating that air, and that reduces the efficiency quite a bit, which increases operating costs. So oftentimes we do run into space constraints when we have multiple pieces of equipment, and that's something to be aware of with the customer. We need to be able to educate them on what we actually need for space for proper operation, for efficient operation, for performance. And then with multiple systems, there's also a lot more repair work that's needed, or a lot more maintenance work that's needed. If someone's not maintaining it, I've had multiple occasions where myself in the field, there's water pouring out of somebody's ceiling. It oftentimes turns into somebody put a condensate pump in the attic that was never maintained. Somebody did their drain lines, but they never actually piped in the drain pan underneath the equipment. So it plugged up and it overflowed and water's coming out of their ceiling. Those are all things we have to take into consideration, and the customer really needs to know about them. There is an extra cost when it comes to multiple systems that you're probably not going to have with some of the other options available to you, especially with zoning. Zoning is very low maintenance. But oftentimes the pros of having multiple systems is going to outweigh the cons, because if you live in a cold climate, you've got two pieces of equipment. One of them goes down, you still have the other. You have heat in your home to prevent freezing. But some of the applications we can look at. When we start looking at our homes, if we have a home that's got a basement and then 3 floors above it, so 4-floor home, that is a much better application for multiple pieces of equipment. You have a piece of equipment that handles the upper 2 levels. You have a piece of equipment that handles the main floor and the basement. That is a great application for having 2 pieces of equipment. So some of the things we run into is a lot of the homes that I've seen that have 4 floors, they're typically in a college town. Then each floor is rented out to a different student, and that student has different conditioning requirements than the other 3 floors. So when we have 2 pieces of equipment, the upper 2 floors are more likely to have the same conditioning needs. The lower 2 floors are more likely to have the same conditioning needs. So those 2 pieces of equipment allow us to more closely meet that. But then once we have that application, because we're still splitting out 2 comfort differences, zoning adds a different degree to that and it complements it really well, because then we can have 4 floors of control with 2 pieces of equipment, and we match our floors based on what they're most likely to need control over. So while the upper 2 floors are more likely to need cooling, the lower 2 floors, or even the main floor, is probably going to be satisfied, but the basement may very well need heating. So having 2 pieces of equipment allows both of those to be served at the same time, and we can match the comfort to the people who are occupying those spaces. So 4 floors, I strongly recommend 2 pieces of equipment. Splitting it out is almost a necessity so you can provide optimum comfort for the occupants. And then zone it down past that, and we'll talk about zoning a bit later. But some homes are very sprawled out, large conditioning differences. This is another home that looks to have 4 floors if they have a basement, but each of those floors is extremely different, and each of those floors could very well use their own piece of equipment, especially as big as that home is. So those are things to pay attention to. How is our customer using their home? Is the ductwork going to adequately service those? The longer the ductwork gets, the harder it is to move that air to the furthest locations, and the more likely it is we're going to run into a problem with under conditioning. But like the previous home, big homes in general, a single piece of equipment's not going to have the capacity necessary to condition these homes, so we need that added capacity. And once we start doing a piece of equipment for each floor, we can then complement that further with zoning to give them a more personalized control on each of their floors. But equipment needs to be sized for the home. When we run into large homes, multiple pieces of equipment are necessary. And there's further optimization that can be done, but we can't necessarily condition, or we can't condition an entire home like that with a single piece of equipment. Look at the customer's home. Is it a large home that's going to have excessive duct length? If it is, then you're probably going to benefit from multiple pieces of equipment that will allow you to shorten those duct length and provide more performance to the airflow distribution of that home. There's times where the vast majority of the home can be covered by a single piece of equipment, but maybe they've got some areas that are really hard to access with ductwork. And that's where ductless mini splits come into play, because now we don't have to get ductwork to those locations. We can provide that area individualized control through a high efficiency ductless mini split. So mini splits, maybe they got an issue with peak capacity. Their furnace or their air conditioner just doesn't keep up with the most extreme of weather. Maybe they've got a sunroom or something like that where they need control that wasn't designed into their original system. So those are the places where ductless units really shine. We don't have to replace our central system. We don't have to do potentially expensive ductwork modifications. We can do the ductless system and handle the load in that home, providing control of that area that our customer is specifically looking for control with. So they add a lot of capacity when it comes to peak conditions. They help to optimize comfort in that area, and they are very efficient. And to that point, if the furnace goes down, if the air conditioner goes down, there's now a backup to the primary system. So they still have an area of their home that can be comfortable while they await repairs on their primary system. Ductwork can be very expensive to add, so if there's no ductwork at all, ductless mini splits make a lot more sense. And they are very efficient. They're very similar to zoning because they provide room-by-room control, because our customers know all about them. They've got really good advertisements, so there's a lot of awareness for them. And they're perfect when there's inadequate ductwork. So a ductless mini split would be a great application for that. But some of the issues we do run into with the ductless mini splits are maintenance issues. Homeowners typically don't maintain their ductless units, and without maintaining their ductless unit, they run into issues with mold growth, smells, odors. It starts freezing up because the wheel gets so blocked that it can't actually move air. So that does add to maintenance, and that's something that customers need to be aware of. That's something they need to be aware of when they're making the decision to purchase that, is that this unit needs to be maintained. And then the parts for them can sometimes be harder to get a hold of. So when it comes to repair, those repairs may be less convenient. There might be issues of aesthetics. How's it going to look on the interior of their home? Is it going to match their decor? Things like that. I know that they can be painted, but that in itself can be quite a headache. The jobs where I've done a ductless unit that needed to be painted, the entire system, all the plastic parts had to be completely pulled off and painted separately. And then it had to be reassembled. So it really wasn't a simple task to match it to the decor in the home. But then when we come to the exterior of the home, when we got a multi-head system, we end up with a bunch of line height on the outside of the home. That can detract from the aesthetics on the exterior of the home. When we run into apartment complexes, now we might not necessarily see that here in America, but in other countries, they've got just walls of condensing units on the outside of the building. It can have some serious aesthetic concerns. And then the more and more line sets we have to run, Some of these locations are difficult to access. That can add to the labor, that can add to the cost, and that can make them less and less attractive. And while they work great, they don't necessarily need to be our go-to option if there's already existing ductwork. A lot of times we just need to optimize it. The great applications for ductless. They don't have any ductwork at all. They have a hot water system. They got a boiler in their home. That boiler doesn't typically leave room for ductwork. With the copper pipes running the way they are, ductwork's oftentimes very difficult to install. But being that they've already got a heating system, they don't probably want to have a large air handler sitting in their home. So ductless units, to provide them conditioning of the points that they need it at, would make a lot more sense in this application. Now, if they want to condition their entire home, the ductless unit may not make sense on the cooling side if they want cooling throughout their entire home. That's something that we're going to have to weigh the pros and cons with. If they have a hot water system, do they just need to be comfortable in a few rooms of their home, or do they need to be comfortable throughout their entire home during the cooling season? And that'll be a conversation that's going to determine what we're looking to do, whether we're looking to do a conventional split system, or whether we're looking just to provide them with the rooms that they actually need the cooling in for that operation. But steam boiler homes, something we run into too often, but they're typically very old homes. Balloon framing, things like that, they don't have the space for ductwork at all. Or those are homes where we're going to have to make those choices of just conditioning specific areas and not doing the entire home in a lot of cases. Now, there are some people that would be willing to do an entire home remodel, but a lot of people aren't going to want to go that route. They just need to be comfortable in a couple of locations. So ductless mini splits make a lot more sense for that application. But in-floor radiant heat, you definitely don't want to start cutting floors if there's water lines underneath of it. The chance of nicking a water line makes for an unpleasant work day. So in-floor radiant heat. Maybe we can come through the ceilings with ductwork. Maybe we can't. Depends on what they've got up above there. But if they've got in-floor radiant heat, the chances of nicking a water line are pretty significant if we try to install conventional ductwork. So a ductless mini split makes a lot more sense. And then we got bonus rooms. Sometimes those bonus rooms are planned into the ductwork initially at construction. Other times they're not. So if that bonus room has no ductwork servicing it, there's no reason that space can't be used, and that can be comfortable. But that comfort's going to end up coming from a ductless mini split. So there are a lot of applications for them. They don't have to be our first go-to option, especially if there's existing ductwork. If they have a central system, we can provide some optimization for it. But if there's a bonus room that's got insufficient ductwork, can't get any more to it. If there's a bonus room that has no ductwork, the ductless mini split makes a lot more sense for that application. If the customer wants to condition the entire home, we really need to look at the split system option versus the ductless option. But if they just need areas where they just need to be comfortable, they're serviced by a boiler, but they have a home office, ductless mini split would make sense for that if there's no existing ductwork. But if there is existing ductwork, we can optimize that. We can improve airflow, air distribution. All right, so let's take a look at zoning systems. You've got two options. You've got 24-volt systems, and then you have our Zell's pneumatic system. We'll talk about our Zell system last, but let's talk about zoning in general right now. Zoning is all about taking your existing duct system and matching its airflow to the occupant's needs in that home or that building if we're in a commercial application. So we're diverting the air, controlling it, channeling it so that we're only conditioning the points that someone actually needs the airflow. So we can direct the BTUs, sending it where it's needed to optimize comfort for our customers. And it's a great complement to any duct system that's out there. But zoning itself is for homes that have existing forced air systems, homes that have room for forced air systems where they want to condition the entire house. And then from there, we further optimize it, directing the air, directing the BTUs, where it's needed, when it's needed. So we can take a home and we can divide it into multiple zones. Residentially, in most cases, aren't going to need to go more than 4 zones. Typically 2 on the main floor, 2 on the second floor. It provides optimum comfort for the occupants because it gives them accurate control of the air, sending it where they need it. So we can put the control pretty much anywhere within those rooms of control, within those zones of operation. Wireless thermostat technology's come a long way, which has made zoning even easier to install because now we can move that thermostat to the location that they really need it in. We're no longer stuck in hallways, and zoning will then direct that air, direct those BTUs where it needs to be at. And zoning can be retrofitted into existing duct systems, so we don't have to rip out all the ductwork to do zoning, we can retrofit it into an existing duct system. It's a great complement to new construction before there's any ductwork available, but it's also a great complement to an existing duct system where they really just need to optimize it and get better control of that air. But use the existing HVAC system, use the existing duct system, so there's very little renovation needed when it comes to zoning installation. The cost can typically be less. Normal zoning job will usually run you about what you can expect to spend on a two-head ductless system. But with that, you get control of the entire house, not just 2 rooms. So it provides you with a lot more customized control, provides your customer with a lot more customized comfort, and all of that with very little renovation to the home at all. And since it's using their existing ductwork, there's very few changes to the aesthetics of the home. Everything more or less stays exactly as it was. We don't have to work with high voltage circuits. So for some municipalities, you have to get an electrician anytime you add a circuit to the electrical box. With zoning, you're not doing that. You don't have to add a circuit, so you don't require another trade to come in and provide that for you. There's very little maintenance. For the most part, zoning is maintenance free. You don't have to run additional condensing units. So if you have a home that it's longer, you can still do that with a single piece of equipment, because once you start to close things down, once you start to increase your velocity in that ductwork, you're going to push more air, you're going to push more BTUs into those furthest locations, and you're going to adequately condition them. But some of the cons that you might run into with zoning is with 24 volt zoning, there's oftentimes you'll have a tripped gear after about 5-6 years of operation. Things start to loosen up, you start to have noise issues potentially with those motors. And then if somebody decided to go through and finish their basement when you were done, you lost access to all those dampers. It makes it very difficult to service if there is an issue that needs to be addressed. And then you can't always access the ductwork. So if you're using 24 volt dampers, that leaves you with runs that you can't access, places you can't damper off without having to cut into the drywall and gain access to them, and that makes it unappealing. Things can get complicated once you start to add a lot of dampers on the system. If you're doing branch dampers, which is going to be typical of an existing home, you now have to start figuring out transformer loading. You have to figure out transformer sizing, and you either have to use isolation relays to prevent tying those transformers together, or you have to phase those transformers so that you can run them in parallel. And that's stuff that's typically beyond the grasp of most field technicians. Now, once you start to get into heavier commercial industrial, those technicians are typically a lot more familiar with it. But when you're in residential light commercial, those concepts are usually out of grasp for most technicians. So zoning itself can get very complicated, and then they give up. They don't take the time to understand it. So the 24 volt systems, though, the wiring can get fairly complicated, the relays can get fairly complicated, and you have to figure out what your power requirements are and size your transformers appropriately, and all that can become overwhelming, it can become confusing, and that has a lot of people throw their hands up at zoning because it's too complicated for them. It's past what they're comfortable with, and they stop there. But zoning has some great applications. Zoning has a lot of use within the residential light commercial markets customers. If there's existing ductwork, there is room for improvement. There is room to efficiently direct that air to the places our customers need it at. So a great application for zoning is going to be with existing ductwork. Our customers have hot and cold spots in their home, and zoning will address that without having to do major renovation. Master suites, those are a great application for zoning, and that's going to be the vast majority of people that are looking for optimized comfort in their home. They want a thermostat in their bedrooms. They want to be comfortable from that bedroom suite. And zoning gives you that capability without having to do major home renovation, making them more comfortable in the room that they spend a lot of their time. But you got 2 floors, you have 2 very different thermal gains. That upstairs is usually going to need a lot more cooling than the main floor. The main floor is going to need more heating than the upstairs. But when your thermostat's on that main floor, to be comfortable there, you're going to overheat the upstairs in the winter months. If your thermostat's on the main floor, to be comfortable upstairs, you're going to have to set it a lot lower and freeze out the main floor to be comfortable upstairs where the bedrooms are at. So when we install zoning in those applications, we now have a thermostat on both floors, and we can direct the airflow, direct the BTUs where they need it to be at based on how they're using their home, and we can provide them with optimum comfort. But maybe they've got a finished basement. Finished basements have very different conditioning requirements, especially since there's very little to no thermal gain on them, being 2/3 or 3/4 of the way buried in the ground. They're usually going to need more heat than cooling. So if that basement's finished, we don't necessarily need to direct the BTUs from the air conditioner down there. So during the cooling season, we probably want to have that closed off so we can move the capacity to the upper floors where it's actually needed at, keeping the basement comfortable, keeping it a bit warmer. So those are great applications for zoning. But when we have a finished basement, it's hard to do a 24-volt system because the duct is inaccessible. It's buried behind drywall. And most technicians that know Murphy's Law know that eventually there will be a time when those dampers need to be accessed, and you're not going to be able to do that without cutting into the drywall. That becomes unappealing to the homeowners, but we need an alternate solution for them, something that's going to keep the system accessible, but provide them with optimum comfort and give them the benefits of zoning. And those are huge. But when we start looking at zoning, there's two options to zoning. There's the 24-volt zoning system, which is a bit more limited for its application, and then there's the RZEL zoning system. The RZEL zoning system has made it possible to zone off the applications that with 24-volt systems can very well be impossible to do. We have dampers to match applications. You have that finished basement. Somebody's got drywall up and they don't want to cut into the drywall for installing traditional dampers leaving access doors. RZEL has a damper designed specifically for that application. You got slab homes. Slab homes you can't do with the 24-volt zoning system if the ductwork's in the ground. RZEL has the dampers for that application. So when we take a look at zoning, when we have our two options available to us, RZEL zoning is going to provide you with the most flexibility. But with that flexibility also comes a lifetime parts warranty. So as long as that system was registered within 90 days of installation, there is a lifetime parts warranty. If the technician runs into a problem, they can call us. Tech support's available 7 days a week. We have our comfort guarantee. If your customer is dissatisfied with their zoning system within the first year of operation, as long as it was designed and installed correctly, RZEL will buy back our equipment. So the panel, the dampers, the tubing, the parts that you purchased from RZEL, we'll buy those back if your customer is dissatisfied within the first year of operation. And when it comes to reliability, RZEL has some of the most reliable dampers on the market. Our easy slide damper that we've been installing for more than 30 years. So with the RZEL system, you've got a lot of flexibility. You've got a lot of versatility. You have a lifetime parts warranty, 100% comfort guarantee. All things that can help you address it with your customer and alleviate their fear of reliability and risk. Now, a lot of times when we're having those conversations with the technicians, we're helping them troubleshoot and showing them that it's not necessarily the RZEL system that's causing their problem, but we're not stopping there. We're helping them past that. So if the problem's with their thermostat, if the problem's with their HVAC equipment, we're helping them narrow it down so that they can focus on where the problem's at. And that saves them time, that saves them money, and it's one of the reasons that we have such a highly rated tech support here. We're available 7 days a week, 8 a.m. to 9 p.m. Eastern time. So we will pick up Saturdays, Sundays. We will pick up on holidays if there's a need for it. But tech support is available to the professionals from 8 a.m. to 9 p.m. Eastern time.